All right, folks, here we are once again. So today we're going to do solving rational equations. And you've done this in kind of a smaller scale in previous courses, such as geometry. So we'll start with a few of those. So let's say we've got 3 over x plus 2 equals 1 over x minus 2. All right, so this is ratio in proportion. Cross multiply. So you would write out here, you have the 3 times the x minus 2 has to equal the x plus 2 times the 1. And now this is simply distributive property. This side there's nothing really to distribute. And then you can subtract x. You get 2x minus 6 equals 2. And then add 6. 2x equals 8. So x equals 4. Now, something that you have to think about when you're doing these problems is domain restrictions. Okay, so your answer cannot contradict any domain restrictions. Now, you could simply think about it at the beginning of the problem or at the end. Usually you wait till the end. Right? So you don't have to declare the domain restrictions. You just have to make sure that it doesn't contradict any. And so here 4, right, doesn't create a division by 0 error here. Doesn't create division by 0 error here. So we're good. Right, another one of those. You can pause the video here and try this one. It's very similar in nature. So the cross product, x minus 3 times x minus 2 would have to equal x times x minus 4. So there's a little bit more work involved with this one, such as multiplying these binomials together. If you FOIL that together, you get x squared minus 5x plus 6. Here you're distributing the x. And now you have, this is a quadratic equation, so it seems. And your tactic for dealing with quadratic equations is to gather everything onto one side, create the other side equal to 0. If you try doing that, you see the x squareds actually go away. And now you simply have a linear equation. And then you solve that. Add 5x to both sides. 6 is equal to x. And again, check against the original problem. X couldn't be 0, and x can't be 2. So you're good. X is 6. So let's see now where we might have one that's a little bit different outcome. So let's do x squared over x plus 2 equals 4 over x plus 2. So you'd multiply, same thing, x squared times x plus 2 has to equal x plus 2 times 4. So this will give me x cubed plus 2x squared equals 4x plus 8. Now this is a cubic, so it would require you, any polynomial equation require you to set everything equal to 0. So I'll bring all these terms over. And then you would attempt now a factor by grouping. And so you have x squared minus 4 and x plus 2. And this actually factors further into x plus 2x minus 2. So you're getting 3 solutions. You're getting negative 2, positive 2, and negative 2 again. Double root. Now you have to compare these to any restrictions you might have from the original. X can't be negative 2, so right away you know these are extraneous. And positive 2 is allowed, so that one is good. All right, let's do some more. All right. So now we'll just start doing ones that require a bit more work because they have more terms involved. So let's do x over x plus 3 plus 1 over x minus 3 is equal to 1. Now, much of the way I'm going to do this problem, some people might think it's a little bit too much writing that is necessary. I'll let you make that determination. But if you do the problems in the way I'm going to illustrate, then you shouldn't have any issues. The first thing is everything should be factored, and everything here is factored. I mean, there's nothing to factor. The next stage would be to rewrite the problem with empty sets of parentheses next to each term of the equation, as well as this one on the right-hand side. Anything that's integer should be written as a fraction over 1. And now you're going to multiply through by the LCD of the problem. So the LCD would be x plus 3, x minus 3. And if you multiply every term by that, you are guaranteed to get rid of all the fractions in the problem in one shot. If you try multiplying through and you don't get rid of all the fractions, that means you didn't use the real LCD. These are all over 1. And now you can cancel common factors. So here the x plus 3 cancels. Here the x minus 3 cancels. And nothing cancels over here. So you have the numerator x times this x minus 3 plus this 1 times this x plus 3 is equal to x plus 3, x minus 3. And so the left-hand side you have a little distributive property, and the right-hand side you have to FOIL. This comes out to be x squared minus 9. I'm going to combine like terms on the left. And now, again, you might think it's quadratic, but if you try to gather the terms, you see the x squareds cancel. And then solve that linear equation. Get negative 2x equals negative 12. So x equals 6. And then compare that to the original. X couldn't be negative 3 or positive 3, so you're good. Then you can move on. One more here of this type. And again, you should probably pause the video here and try this one on your own. All right, so 1 over x plus 1 minus 1 over x plus 2 equals a half. You pause the video and try it. Remember, write everything out with empty parentheses next to each term. the LCD for this problem would be x plus 1 times x plus 2 times 2. So that's actually all of them. I'll put the 2 in front. And again, once you do a few of these, some people skip a little bit of these writing steps. You're going to have to decide what works for you. So now here, this x plus 1 cancels. Here the x plus 2. And here just the number 2. So what do we have left here? We have this 1 times 2 times x plus 2 minus this 2 times x plus 1 equals x plus 1 times x plus 2. Now be careful here. This second term, this product here, is actually grouped together. So when you multiply this, you get 2x plus 2, but this subtraction sign is really distributing through this quantity. So it's going to be minus 2x minus 2. That's really where many mistakes are made in just that one step. Right hand side, FOIL, and now I've got the 2x minus 2x cancels out, and 4 minus 2 is 2. This side, leave alone for one step. Subtract 2, because you want to set one side equal to 0. It's a quadratic equation. And now you have to factor. Now this one doesn't require AC method. This is just GCF factoring. X comes out. And you have your zero product property. You get x equals 0 and x equals negative 3. Check those against the original problem. X can be 0 here. X can be negative 3 here. No problem. They're both going to check out. All right. We'll keep going. So we'll do 2 more. Again, I encourage you to pause the video each time and try it on your own. 2 over x minus 1 minus x over x plus 3 equals 6 over x squared plus 2x minus 3. Now I'm going to rewrite with empty parentheses next to each term. Also, I'm going to factor this denominator because it's going to be helpful for you to determine the LCD when everything's in factored form. So if I look at all these denominators here, the LCD would be x plus 3 times x minus 1. X plus 3 times x minus 1. I'm going to multiply all the way through by that. And start canceling out. X minus 1 cancels here. X plus 3 cancels here. And here all of these quantities cancel out. So the right-hand side is just the number 6. Here on the left, I've got the 2 times x plus 3. That's 2x plus 6. Now again, here, remember, this is grouped together. So when I multiply this x times this x minus 1, I would get x squared minus x, and then apply the sign change to those terms. So it'll be minus x squared plus x. All right, on the left, I'm going to kind of just rewrite, combine like terms. Negative x squared plus 3x plus 6 equals 6. And I like to have a being positive. So I'm actually going to bring everything to the right-hand side. subtracting the 6's, those will cancel out. And then I'll just have x squared minus 3x. It doesn't really matter. You can factor it while it's on the left. I just prefer it this way. And then, much like the last problem, you have a GCF of x. Factor that out. You get two solutions, x equals 0 and x equals 3. And just check these. Okay, 0 is allowed and 3 will be allowed. So these will both check out. And one more for good measure. Let's do 3 over x squared minus 7x plus 10 plus 2 equals x minus 4 over x minus 5. Again, pause it here. Try it on your own. I'm going to factor this denominator. That's x minus 5, x minus 2. Then put my empty set of parentheses. The 2, you should always be writing integers as fractions over 1. Put empty set of parentheses there. And then the right-hand side, empty set of parentheses there. So I see here I've got x minus 5, x minus 2. And so that is going to be my LCD. X minus 5, x minus 2. I'm going to multiply all the way through by that. And I can start the canceling. So here, the x minus 5 goes, the x minus 2 goes, and all I'm left with is just this 3. Here, there's nothing to cancel. So I'll have the 2 times, I'm just going to FOIL this right up here. Remember, that's x squared minus 7x plus 10. So eventually you're going to have to distribute the 2 into that. And here the x minus 5's cancel. So I have x minus 4 times x minus 2. So still some more work to be done. Distribute. Right hand side is FOIL method. And I'm going to combine like terms on the left. So it's going to be 2x squared minus 14x. This 3 plus the 20 becomes 23. And now I have a quadratic. And I need to set it to equal to 0. So I'm going to subtract x squared. I'm going to do this all at once. Subtract x squared. Add 6x. And subtract 8. Gives me the 0 that I want. This is now x squared minus 8x plus 15. Nicely enough, this is factorable. You might encounter a situation where it isn't, and you would actually have to go and use the quadratic formula. But this is factorable. It's x minus 3, x minus 5. And this is going to give me two solutions here. X equals 3, x equals 5. Now I have to check these against the original. The 3 is fine. The 5 is not fine. Right? You can't plug it in here. Right? This was the factored original. You could see it here if you just substitute the 5 in. You'd have 25 minus 35 plus 10. That's 0. That's bad. It's easier to see on this fraction. Right? 5 minus 5 is 0. So this 5 is extraneous. You can't use it. So the only solution to this problem is x equals 3. So keep organized and try to not get caught with this mistake up here of distributing negatives into quantities, and you should be okay with this. Good luck.